3.1 through 3.3, solving systems word problems. Read and highlight. Let's go to work. A word problem of systems of equations will mean that we need to write our own equations for the problems before beginning the solving process. We'll work through a few common examples of system word problems working the equations together, but leaving the actual solving as an exercise for you. So we're going to set them up, but the solving is for you. Note of caution, some problems may be able to be solved using the guess and check strategy, but no credit will be given without work. So make sure you're showing your work. Since we've been given some specific methods to solve systems, we will be expected to use one of those methods. What were the methods for solving systems? Just as a quick reminder, we had by graphing, we had substitution, and we had, finally, the elimination method. Make sure when you're doing your work to solve that you're using one of those three, okay? Frodo bought 7 packs of Yu-Gi-Oh cards and 3 packs of gum and paid $29.19. Bilbo bought 4 packs of Yu-Gi-Oh cards and 1 pack of gum and paid $15.98. How much for each pack of Yu-Gi-Oh cards and each pack of gum? The most important thing to do is to define your variables. In this case, we want the cost of each thing. So we'll let Y be the cost of the pack of Yu-Gi-Oh cards, and we'll let G be the cost of the pack of the gum. Since we get the total cost by multiplying the number of things that we buy by their price, we can write the following equation for Frodo. 7Y plus 3G equals 29.19. 7Y for the Yu-Gi-Oh cards plus 3G and paid $29.19. See how that's done? Okay. What about the other? Let's go blue. In other words, 7 times the cost of Yu-Gi-Oh cards plus 3 times the cost of the pack of gum gives us a total of $29.19. In the same way, we can write the equation for Bilbo. 4Y plus G equals $15.98. In this case, substitution or elimination may work best since you need an extremely zoomed in graph to be accurate to the nearest hundredth. So I would suggest that you do it algebraically. Either way, you should get the solution that Y equals 375 and the gum is 98 cents. Notice that it doesn't necessarily make sense to write the solution as a point like we have been doing because it's not X and Y, but rather the price of the Yu-Gi-Oh cards and the price of the gum. Again, letting you, once we have the 2 different equations, letting you solve is up to you. We're just setting it up for you in this section. What about age systems? John Luke's age plus William's age is equal to 95. John Luke is 11 years older than William. How old are John Luke and William? Well, in this case, we define our variables by let J equal John Luke's age, W equal William's age. Now we can write the equation to show their total age. J plus W is 90. I guess that should have been 95. I think I see an error right here. See, it says 95, so that should have been 95. Oops. Should have been 95. Okay. Since the problem states John Luke is, we know we'll start with the second equation with J. Since he is 11 years older than William, what would William's age be plus 11? Therefore, we can get our second equation to be, oops, hard to go back from that highlighter to the pen, and I don't want it to be blue, I want it to be yellow. J equals W plus 11. In this case, substitution may work best. So I'm going to go ahead and do this because we have the wrong number in here. So this, let's go to red. This can take the place of J there. So I have W plus 11 plus W equals 95. So 2W plus 11 equals 95. Subtract 11 from both sides. So 2W equals 84. Divide by 2. W equals 42. Now I got to plug that back in here. So J equals 42 plus 11. So J equals, what, 53. And we can see that they had done the work properly. It was just that one error right there putting down that 98. Good. Hope that you're seeing how this can be done. We got to come up with the equations on our own. Sometimes it could be a how many system. An amusement park charges $11 for a child and $25 for an adult. If one day the park made $37,250 and had 2,000 people attend, how many children and how many were adults? Well, we know first that there were 2,000 people, children and adults. So we'll C plus 2,000. So we're looking for the number of adults and children. So we have A be the number of adults, C be the number of children. With that in mind, let's start with the total attendance since it's an easier equation. Number of children plus the number of adults is the total number of people attended. So C plus A equals 2,000. Simple enough. The second equation will have to do with the money aspect of the park. Again, find the total money made by multiplying the price of admission times the number of people in that age group for both. Then we add them up. So 15 for children plus 25 for adults and gave us a total of 37,325. Now, in either case, either substitution or elimination would work nicely. But for substitution, the first equation, you could solve for either variable. For elimination, you'd have to multiply one by either coefficient of the second and then subtract. Either way, you find a solution is children was 1,275 and 725 adults. Cool. Finding two number systems. The sum of two numbers is 214. The first number is 18 more than 3 times the second number. What are the two numbers? Well, first we need to carefully define our variables. First, we'll let F be the first number and S be the second number. We know the sum means add, so our first equation is F plus S equals 214. The second equation, we'll let F, we'll start with F since it says the first number is, and then we'll have 3 times the second number plus 18. So F is 3S plus 18. I would suggest substitution because the F is already isolated. We should find a solution to be S is 49, F is 165. Another common type of system is a rectangular system. A rectangle has a perimeter of 42 and a length that is 5 less than the width. So this is two different things. I'm talking about the perimeter 42, and then the length is 5 less than the width. What is the length of a rectangle? Sometimes it helps to draw yourself a picture. And if that were the case, you got one picture, you got width, length, width, length. That may help. If you add all those up, that would be 42, or if you just do half of it, that'd be 21. That's the way they're going to look at it here. we'll let L be the length, W be the width. And we can handle the perimeter in two ways. We know the formula of the perimeter is, so we could use that. However, it may be easier to realize that when we divide that equation by 2 on both sides, the fact that the sum of the length and the width is half the perimeter. So let's use that. And they decided to use L plus W equals 21. And then the second equation, since the length is 5 less than the width, the second equation would be L equals W minus 5. Again, it appears substitution will work nicely because they already isolated the L. So we will get the solution with this 13 and the length of 8. Don't forget the units when dealing with that. So there's a way to look at and find the equations in word problems. We make it look really easy here, and I know it's a lot more difficult than that, but take your time, define your variables, and see how they go together in each situation, and realize you're going to have 2 equations for each. So that was 3.1 through 3.3 word problems, reading and highlighting. Good luck.